So if you look at this front page, is there a problem that is intimidating? Yeah, 6 looks good. I think the only thing intimidating about number 5 is the sign in it. And I think that it'll work out fine. I think I'd rather do number 6 because of the negatives, and I think the negatives can get a little hairy. Not literally, of course. You don't need to get out like a razor blade or, like a shaver or anything. That was a joke. Bad joke? I said hairy? Okay, I'm gonna stop. Okay. So let's do number 6. The purpose of implicit differentiation is to say that normally we take a function. Zoom. Was it? Nope. That's because I moved this up last period. Zoom. The purpose of implicit differentiation is to say normally if we were doing the derivative, the y would have been alone. So normally we would have said like dy dx equals the derivative. But here, the y is in the middle of the problem. So whenever we see the y and we take like the derivative of that, we stick a dy dx after it to say that's going to represent the entire derivative of the equation if the y had been solved for. That's the basis of the implicit differentiation because the y wasn't solved for. So we can't assume that we know what the entire equation would have been if it had been solved for. All right, clear as mud, cool? All right, let's go ahead and start this one. So the derivative of y to the 5th is 5y to the 4th. And then we just stick a little dy dx on the end. Now, most people do dy dx, but I have seen people do y prime. So if you want to do y prime because it is less cumbersome, that's fine. I think the reason that when they first teach implicit differentiation that they don't do y prime is because students might, with the y prime, it's so similar to y, they might lose it in the problem. Whereas dy dx like really sticks out. And so then you're not going to lose it anywhere. Okay, so I'm going to do dy dx. My answer keys have dy dx. But if you want to do y prime because this is obnoxious to write, you can do y prime and you are not doing something wrong. Okay, it is up to you. All right, now we got minus. This is how I do it. I don't think of it as a negative x squared. I do minus and I do parentheses. Okay, that is my personal preference. Okay, minus. All right, and then we got a product rule. So how do we do the product rule? And I'm thinking of this. I already took care of the minus, so I'm thinking positive x squared times positive y to the 3rd. How do I do the product rule? Okay, so x squared times 3y squared dy dx, okay, plus to 3. Y to the, you can't even tell that's a 3. Y to the 3rd times 2x, okay? So I took the whole derivative of the left side, okay? I wrote too big. This is unfortunate. All right, and then when I do the derivative of the right side, what is the derivative of 1? 0. And then I've got a negative sign, so I'm going to do the same thing again. I'm going to put this in parentheses, and I'm going to think of this as a product rule where I have a positive x to the 4th multiplied by a positive y. Okay, so what do I do now? 1 dy dx. Okay. And then plus y times 4x to the 3rd. I almost had room. Okay, so there it is. Beautiful. Okay, before I worry too much about the next part, I'm just going to get rid of my parentheses, and then we can work on the next part of the conceptual understanding, okay? So I'm just going to clean it up a little bit. 5y to the fourth dy dx minus 3x squared y squared dy dx minus 2xy to the third. Are we comfortable with that? I took my coefficients and moved them to the front, and then I distributed my negative at the same time. Comfortable? Okay. Gonna do the same thing on the other side. So minus x to the fourth dy dx minus 4x to the third y. Okay. Now, after we have done the derivative, what is our goal? Yeah, isolate, not the y, the dy dx. So we want every term with a dy dx in it on one side, and every term without a dy dx in it on the other side. And it doesn't matter which side you choose. So since I have two terms with dy dx's on it on the left side already, I'm going to go ahead and take this one and move it over here. And I'm going to take this one and move it over there. So I'm just going to get all my dy dx's onto the left. So I'm going to have 5y to the fourth dy dx minus 3x squared y squared dy dx plus x to the fourth dy dx equals positive 2xy to the third minus 4x to the third y. Technically, if I was writing these correctly in standard form, I would have put this one first. But in calculus, people don't nitpick that as much. They just don't care. So students don't like to do problems where they're showing their work tediously, but the best way to avoid making mistakes, especially when you first learn something, is to show the work even when it's tedious. Okay? So doing this part when you first learn it is beneficial. If you have done it 15, 20 times and you get it right every single time and you want to start to skip steps, then start skipping steps. But in the beginning, when you're doing it, I wouldn't skip steps. Okay? All right, so what is the next part? Yeah, take dy dx out as a GCF. Don't take the whole GCF out, just dy dx. So 5y to the fourth minus 3x squared y squared plus x to the fourth. Again, if you want to fix the order and make it so that it's technically like correct standard form, you're welcome to. Am I worried about it? Not really. Would it be in the correct order on a multiple choice problem? Maybe, maybe not. On an FRQ, it doesn't matter. Okay? All right, and then what do I do? Divide the whole parenthesis. Now, these problems, before you look at the answer key and go, oh, I got it wrong, check the order of things, check the signs, because maybe I put the dy dx's on the right and you put them on the left, and so all of our signs are completely opposite of each other. Or maybe I rearranged things and you didn't. So there's some variation in the answers, even if they're technically equivalent. So just be careful before you decide, oh, my answer's wrong. All right. Be careful also of killing puppies today. So you would kill a puppy if you were like oh, there's an x here and an x here, I can cancel those out. No, you can't. The only way to cancel is if you could factor out a GCF on the top and factor out a GCF on the bottom, and then your GCFs could reduce. But when there's pluses and minuses, you cannot cancel. That's how we kill puppies. Okay? Yes? No, x to the fourth. Thank you for noticing my typo. Get it? It's a funny joke because I'm handwriting. Oh, that was good. That was good. Oh man, my favorite is with the masks. When you get embarrassed, you can literally do the like turtle on the shell thing and just pull the mask over your whole face. That's my favorite thing about masks right now. Is that when you're embarrassed, you can actually hide. It's good. All right. How do you feel about implicit? Doesn't that look insane? Go show that to your parents and be like, look at what I did, and they'll be like, you're amazing. And then you'll be like, but this, I would argue, this isn't actually the worst thing we've done. Like, we've done worse. It just looks real bad. It looks insane. Okay, how do you feel? Is it okay? A little better? Do you feel intimidated by any others? Like, do we need to do another one, or maybe, okay, other page. What about 7 through 10? Yeah, they did get worse, so maybe we should do one of those. Okay, which one? 9? 9? Okay, so we feel worse about the square root than we do about trig. Is that what we're saying? Because we're choosing 9 over 8 and 10? I'm just clarifying. I'm just clarifying that that's how we... So 10 instead? Okay. Do you like that I clarified that? Because we're realizing at this point that the derivative of square roots is they're kind of evil because they always end up on the bottom of a fraction, and then there's always nastiness. So we've learned that. We've learned that those are kind of terrible. But we're also like, oh, trig is scary. Okay, so there's 2 different types of scary on today's assignment. All right, so do we want to do 8, which, if you guys can tell, it has signs, and it has, so it's got a product rule here, y and sine, but within that product rule, it has a chain rule. So that's one type of scary. This has tangent, and then it has a quotient rule in it, which is part of, so the tangent and then the quotient rule inside is part of a chain rule. So should we do number 10? Okay. All right, so when we do the left side starts with tangent, so we have to do the derivative of tangent, but keep the inside the same. So we're going to do the chain rule, okay? So do rule, derivative of tangent is secant squared, keep the inside the same. I was going to write an x, that's not keeping the inside the same. Okay, keep the inside the same. Times the derivative of the inside. And when I do the derivative of the inside, I'm doing a quotient rule. Okay, so talk me through the quotient rule. How do I do that? Low d high. So I'm going to put this in parentheses. I'm about to have a fraction. Low d high minus high d low. What's the derivative of the bottom? dy dx divided by low squared. This was the right choice. This is the one we should be doing. Okay. So we did the derivative of the outside, keep the inside the same, multiplied by the derivative of the inside. Do we feel good about the left side? We have done it. We're like, I did it, but I don't like it. I did it, but I don't like it. Okay, thank goodness the right side is better. What's the derivative of the right side? 1 plus dy dx. Okay. Ugh. Okay. All right, I'm just going to clean this up a smidge. Some of you guys are like, Ms. Rice, I already had that cleaned up. Okay. I don't like the y squared on the bottom. I don't like it. How could I fix that? Because it's a fraction. I don't need to do that because I'm not taking a derivative. So I'm not really worried about that. So think about what our goal is. Our goal at this point is to clean things up, to get rid of parentheses, and to eventually have separate terms. So you can't subtract it. Our goal is to eventually have separate terms so that we can get the dy dx's on one side. But right now we have multiplication and division happening, and so we can't just add or subtract terms over. We have to do some simplifying to get rid of parentheses, to get rid of the y squared on the bottom, stuff like that. So what could we do to kind of start to simplify stuff? Multiply by y squared. So if I multiply by y squared on the left side, it's just going to cancel out with that y squared on the bottom. It's just going to get rid of it. No, because this is a multiplication. So it's secant squared multiplied by something that is being divided by y squared. So if I just multiply by the y squared, it's just going to cancel out that division. And then I need to multiply by y squared on the right side as well. So on the right side, I have y squared plus y squared dy dx. Are we okay with that? Okay. Now let's get rid of the parentheses, not these parentheses. Those are going to stay because they're just around the angle. So we're going to keep those. But let's get rid of these grouping parentheses that are around the y minus x dy dx. So how could we get rid of these grouping parentheses? Starts with a D. Distribute. We're going to take the secant squared, we're going to distribute it inside. You can do that. Because we got rid of that y squared on the bottom, so we can do that. Well, we could have done it with the y squared on the bottom, but it would have been yuckier looking. So now we're going to have y secant squared, x over y, minus, you can put the dy dx. I like keeping it on the end of the term. So I'm going to call this x secant squared, x over y, dy dx. Are we comfortable with that? Mm-hmm. How are your brains? So we took the derivative was messy. This part, I think you guys, if it had not looked like this, if it had just been like 1 minus x over 5, and this had been a 2 out front, I think if it had been numbers, you would have been more comfortable. It's the fact that it's not numbers and that it's trig and it looks crazy, that's what is keeping us from remembering how our math rules work. Does that make sense? So these are math rules that we've done before. We're just forgetting how to do them because the problem looks different. So this is a trick that I learned from a college professor, is he would just, whenever I didn't know how to do a problem, he would write off to the side what my goal was, but he would put it in numbers instead. So he'd say, like, this is what we're trying to get to, right, is the dy dx. So he'd say you have like 1 minus 2x over 5 with a 3 out front, and you don't want the 5 on the bottom, what can you do? And I'd be like, oh, multiply the 5 over. Because with numbers, you guys have a little bit more intuition. Does that make sense? You have more common sense with numbers than you do with this. So if you're having a hard time doing these, take the, sorry, it would have had like an x in here, because the dy dx is what we were trying to get to. Take the problem off to the side, write it with numbers where you're more comfortable, and then think through what to do. Because then when the 5 is gone, if I said, what do I want to do? If I want to get rid of the parentheses, you'd be like, oh, distribute the 3. No big deal. But as soon as I go back to secant squared, you're like, we can distribute? That's crazy, right? But with the numbers, is like not the crazy. It's not crazy at all because you've been distributing like your whole math career. Does that make sense? Okay. So that was a trick that I learned in college from the least capable math teacher I've ever had. He was terrible at explaining math. He hated teaching math. He was like a mathematician at heart. And that was like the one takeaway I had. I was like, wow, that was actually very helpful. That's like the only thing you've ever said to me that made sense. Thank you. Beautiful. It helped, I mean, the whole accent doesn't speak English. Also made it hard to learn. Okay, we're gonna move on. All right, so do you guys want to move the dy dx's to the left side, or do you want to move them to the right side? Right side? Do you guys want to keep it positive? I like it. Okay, so let's go ahead and take this, and then we'll move it over here, and take the y squared and move it to the left. So y secant squared x over y minus y squared. All right, and then what do? Pull the dy dx out. Okay. And then what do? Divide that mess by this mess. Can we cancel out the secant squareds? No. Can we cancel out the y squareds? No. Doing either of those things would kill a puppy. Please don't kill puppies today. I'd be very sad. When I graded the test yesterday, you guys killed 4 baby goats, which are called kids. So you killed 4 kids yesterday. You kill a kid, well, so it's up there as you didn't use the chain rule, and you guys like partially used the chain rule, but didn't completely use the chain rule, and I counted it anyways. So actually, let's put our pencils down. We're gonna take a moment in silence for the 4 baby goats that died yesterday for our careless mistakes. All right. Okay. So I'm gonna give you guys some time to work. Oh man, that was good. That was good. That's right. That was a good one. I'm gonna give you guys some time to work. I'm gonna get the percentages done for your test so I can hand them back. And then I'll just be around to answer questions. Sound good? Marvelous.